Hi, we're going to be making Iron Gull ink today. I'm Ian the Green. This is my daughter Spee, who will occasionally photobomb in. And Iron Gull ink is an ink that was used in the Middle Ages all the way up until about the 1950s. It's one of the more important inks on the planet. We're doing this for the SCA, but anybody who's interested in ink making is more than welcome to the process. The first things first, what kind of ingredients do you need? You need water-based liquid. So we are going to be using distilled water, which is our analog to period versions of rainwater at the time, which a lot of the recipes will call for. But they're also call for things like vinegar and beer and wine and, yeah, weird, right? But it's all water-based, and it does serve its purpose. There's some good scientific reasons for it. Won't delve into those today, but we are going to be using store-bought distilled water. It is not as good as the distilled water you're going to get in the lab, but then again, I don't want that. Rainwater today has a pH of about 5. Rainwater back then, we know, had a pH of around 7. So yeah, we want something that has a little bit higher pH in this case. All right, so we'll be doing that. Next ingredient that you need for Iron Gull ink or Oak Gull ink are the gulls. And there are a lot of, Elena, you will stop. There are a lot of different kind of gulls that are out there. These are what I call paper gulls, and that's because they're papery and crinkly. Okay? On the inside, though, a lot of them have fluff. Now, if these look light and airy and they don't weigh like much, you are correct. That's exactly correct. Over here, we have some oak gulls that came to us from the Pacific Northwest. These are also light and airy, but they're not hollow. Okay? They feel like styrofoam. But they're not. Both of these are going to have tannic acid in them. Tannic gulls, oak gulls from the United States have about 50% tannic acid in them by weight. If you go over to Europe, you're looking at roughly 60% by weight. And then the Aleppo oak gall, which was used in the Middle Ages as considered the best oak gall out there, has about 70%. Now that's plus or 5 either side. Mother Nature doesn't care too much about quality assurance, so we deal with what she gives us. All right, so for the third ingredient, you need something that is iron. And that iron can come in a variety of different sources. Scrap iron is perfectly fine. The problem is when you're using iron filings or scrap iron, well, as we all know, water doesn't like to dissolve. Pardon me, iron doesn't like to dissolve in water, right? It takes a long time for those iron ions to end up coming out. So there's a variety of ways to handle that. You can heat it up, which then excites those ions around. You heat it up to a nice cherry red, you throw it in, you get a bunch of steam, but you also had a lot of those iron ions bounce off and come into solution. The other way to do that is get something called blue vitriol or copper sulfate. Okay, it's copper sulfate is what it is. And on the chemistry reaction chart of reactive metals, iron is more reactive than copper. So you get this blue crystal copper sulfate stuff, and that'll dissolve into the water. And then you put an iron in there, and it's really interesting. You get to watch the copper fall out, and the iron goes into solution simply because iron sulfate is the thing, and it's more reactive than copper sulfate, so it's going to take the place of the copper. And it's really interesting when you do that because it'll line up whatever container it is with that copper. Or you can get copperas. Copperas is iron sulfate. Wait, it's copperas? Yes. Okay, you can get it at just about any store that you buy your garden supplies at. In fact, that's where I got this at. And it's just iron sulfate. That's all it is. Now, why is it called that? Well, if you get iron sulfate with or septahydrate, which is 7 H2O molecules along with you in that crystal, it's green, much like the color of rusted copper, thus copperas. They didn't necessarily know that it had iron in it, they just knew that it worked. This stuff is almost infinitely dissolvable in water, 98%. It is amazing. Now, if you want to get something that you know is going to be a lot purer, you can go ahead and order it from just about any chemistry supply place online. I don't know how old this is. It's about, it's a kilo, 2.2 pounds, plus or minus, depending on how exact you want it to be. And I haven't run out yet. I've been doing this for a while. I still haven't run out. So those are your 4 basic ingredients: water, iron, galls. But then you're going to need a binder, and we'll show you the binder a little bit later. We are going to be using gum arabic, which comes from the acacia tree, so gum acacia is what more and more people are starting to call it these days. But you're not going to ever find it called that in any of the sources. It's all Arabic, gum arabic. Or sometimes you'll hear it called gum. At that point, do not assume gum arabic. Pretty much any fruit tree is going to produce a gum sap. Okay, apple, pear, cherry, they all produce a gum sap. And if you can't get gum arabic because, well, gum arabic doesn't grow where you live, and for whatever reason you can't trade to get it, you're going to use whatever you can. And gum arabic is the stronger one, and it is the easiest to use, but you'll use what you can get. So anytime you see gum, don't assume gum arabic. It could have been anything. All right. You can use a fire pit if you want. We're going to use a gas stove today. You notice that we're outside, and that's because oak galls have something called tannic acid in them. We discussed that a little bit earlier, if I remember correctly. We're going to boil acid. Stop and think about that. Do you really want that indoors where you're going to breathe it in a concentrated form? I know I don't. I have asthma. That would be bad. So we're going to just boil it out here. How much do you use? Well, most of the recipes you find will say, this amount of liters. Hi, you can stop now. Or 3 cups of this or whatever. First of all, those measurements are in that time and in that place, and we do know what those are and translate to today. The problem is we don't know which one they were using, because you have beer pints and all sorts of other things. So we're going to use a gallon of distilled water. This is going to boil down, and when we're done with it, we're just going to have about 3/4 of a gallon when we're done. So that's an average. It can be more, it can be less. That's my measuring tool is, oh look, it's a gallon container. Now when it comes to everything else, I actually have a scale. And what we're going to use is 6 ounces of oak galls. Oh no, we're not. The normal recipe is 6 ounces of Aleppo oak galls, 70% tannic acid. We don't have those. We have American oak galls today. It's at 50% tannic acid. So we have to do math. Okay?
Oh, I'm out.
Yeah, right?
Just kidding.
So it's going to be 5/7. Don't worry, I'll get a calculator out. I'm not doing this in my head. And I have to figure out what the weight's really going to be, because it's 6 ounce Aleppo oak galls, 1 ounce iron sulfate, and 1 ounce to 3 ounces of gum arabic, depending on how thick I want the ink to be. The ink recipes that we find in period use what we would call a stupidly large amount of gum arabic in it. And that's because they're using a waterproof implement to write with. It's a quill. And so it travels differently. And they wrote on a slope, so it travels differently. So I have found that I put it in a smaller amount, and then if I want it to be thicker, I can add some later, because you can't take it out once it's in. All right, so we're going to boil that up, and this is the boring part where you wait for it to boil up. I'll show you when we put the galls in, don't worry, but I'm going to do some math first. All right, so the math is that I need 8.4 ounces of galls to get the same amount of tannic acid that I would get from 6 ounces of Aleppo oak galls. Now that's great, okay? This is by weight. We're going to be fine. It'll be wonderful. These are paper galls. Entire full can, okay? make sure we tear this out so that it comes down to 0. All right, and the wind's going to keep blowing on it, but it's only going to be 2 gram difference. And we're going to dump them all in here. All right, that's pretty much full to the top. And we get less than 20 grams. Okay, so you're going to be collecting these all day long if you're going to try it, or you're not going to be able to make as much as you want. 28 grams, by the way, to an ounce. That wasn't even an ounce.
What?
Exactly. So, now we have these that were sent to me from the Pacific Northwest area, I think Oregon. Fill it up. Still have the tear. Put that down. And we're not even at 150 yet.
What?
So, we're going to have to find a way to make this work.
Oh
Thank you very
no,
much.
how do we do that?
All right, so we have a volume issue. This much, we only have so much water, right? And at a certain point, we have too much volume here for the water that we have in there. It's like trying to cook spaghetti in water with just enough water covering, with the spaghetti filling the whole pot. It's just not going to cook right. I'm not going to tell you it's not going to cook. I'm just going to tell you it's not going to cook right. And so, quickly did the math, and we need about, for the amount of, we have 150 here. We need 253 grams. We have 150 grams. I switched over from ounces simply because grams are more specific and easier to work with, and you get a better answer with the math that way. But you can, it all works out to ounces. So we're going to use, so it came out to about 2/3. So we'll go ahead and boil this in there, and then it'll boil down to about 2/3 of the gallon. Remember I said we're going to lose about 1/4 of that anyway. We're going to have 70% of 3/4 of the gallon when we got done. We'll just keep boiling it down, and that way we'll get the concentration that we need. So, the fun thing about these guys is that, like styrofoam, they float.
Mud pies. Mud pie.
So, this will go on top to hold them down.
Mud.
Now, should I break these up and make it easier? Yes. So one of the rules of chemistry is very, very simple. More surface area equals more reaction. It's that simple. Okay? It's why a block of sugar acts differently than crystallized sugar, right?
Mud.
It's the same idea. Powdered sugar is still crystallized sugar. It's just been much, much smaller pieces, so you have a lot more surface area. It reacts differently. It dissolves quicker, right? 2 tablespoons of liquid to a cup of powdered sugar, and you end up with this icing. Try and do that with crystallized sugar, and it just doesn't work.
Mud.
Okay? Again, more surface area gets more reaction.
Mud. That's not it.
So that just means this is going to take longer. Now, I did mention that it floats. There we go. Oh, look, it's still floating. Not the wisest thing to do. It's got closed containers in there of liquid. Yeah, I'll do that. There we go. My backup stuff, in case I needed to add more, which doesn't seem to be the problem today. And now the boring part. We wait for it to boil, we wait for it to get to the right color, and yeah, that can take anywhere between 20 minutes and 4 or 5 hours, depending on what's going on. I expect it'll be ready in about 45 minutes, but expectations are not always met. See you then. So on this foam that you're seeing here, you kind of get to see some caramelization type color. Well, it's not caramelizing, okay? There's no Maillard reaction going on there. If you don't know what that is, don't worry about it. If you do, good for you. but it's brown, right? And that's the tannic acid coming through. If you look at kind of like around the edges of the bubbles, and so we are extracting tannic acid here. How far into this are we? I don't know. I haven't been keeping time. I quit doing that a while ago because I learned what the process was and where we would be at in it. But if you end up making ink, you can actually set the timer and then figure out what colors are at what times. Write those down. You become very scientific observations when you do that. And then you'll find out another day with the same type of ingredients, same amounts, the number's going to be different. And so you kind of find out where things are at. Now, one of the things that I have to point out, because this is being videoed, is that your elevation matters. Okay? And anybody who bakes or cooks on a regular basis knows this, especially if they live at a higher altitude. Most recipes are written for people that are below 3,000 feet, or quote sea level. Sea level obviously is 0, but anything under 3,000 feet, most recipes are written for that. But as you go up in elevation, you have less pressure from the air, so water boils at a much lower temperature. 212 Fahrenheit, 100 C is normal. But if you're at if you live in Denver, Reno, Nevada, those places that are mile high and up, you're boiling more like 190 something. So that's a good 10 degrees lower on the Fahrenheit scale, and that's really going to affect how things cook. Also, because air pressure is not so strong, any bubbling effect you have is going to be larger. So again, things change. You're going to change your recipes to match where you're at in elevation. And so we are currently well below 3,000 feet above sea level. And so this is all basic recipe stuff. Adjustments will have to be made depending on your elevation. But currently, that's what it looks like. Oh, and the foam's gone away. And that tells us something different. Although I don't normally have to have one of these in there to hold it down. That tells us that we're going through a cycle here. And when it bubbles up like this, we're getting more tannic acid out. And when it goes away, there's less tannic acid coming in. It's just dealing with itself as opposed to breaking down a little bit and releasing some bubble-ish stuff. That's the difference. That's all. So it's you're definitely starting to smell the acridness, which is that acid smell, acrid acid. Okay, and so we're going to go ahead and take a look and see what we've got. You can see that it's boiled up to this line because, well, you got a line of stuff there. So let's take a look at it. Yep, we've definitely boiled down water, and they're now, as you can tell, waterlogged because they're not trying to float up anymore. Okay, which means we got to squeeze them to get it back out. Okay, and that takes us something. But look at the rich color that we're getting. Okay, now I don't know if it'll come through because steam is a problem on film, right. But that's a nice brown. Okay, and if that was your coffee, you'd be like, who put too much creamer in it, right? Or yeah, you're not done brewing that. Okay, so what you want, the color that we're looking for is a good coffee color or a good dark tea color. Okay, now that just means we need to boil it some more, but we're moving along pretty well. By the way, if you've worked in the restaurant industry, you know why this doesn't hurt. Don't do what I just did, okay, for the normal person. But as you can see, we've got all that. It's very, very soaked.
Oh, yeah. Like a tea bag.
Yep, and so we're going to have to squeeze that out later if we want to use it. Now, we don't have to. If we don't, the amount of liquid we're going to get is very, very minor. So we're going to spend some time, well, with these particular gulls, squeezing them out. Because they may feel like styrofoam, they act like sponges. Thank you. Oh, that one was juicy. Yeah. So, see how black that is? Black coffee, right?
Yep.
Dark tea. Well, that's what we want. That's how much we have. And it's only that much.
Yeah.
The rest of it is in here. So we're going to smash it up. and get it out. Now, is this the normal process that I go through? Absolutely not. But it's the process you go through if you use these kind of gulls. So that's what we're going to do today. So we started off with a full gallon, and that's how much liquid we have right now. That's not what you normally have. Again, we're having to squeeze it out of these gulls. So yeah, we got a ways to go.
Here, you want
If you want to know what that is in ounces or cups, we're about 2.5. So at 2.5 cups, how many cups are there to a gallon? Well, let's do the math. There's 4 quarts, right? 2 pints to a quart, which means there's 8 pints. 2 cups to a pint, there's 16 cups to a gallon. This is 2. No. It's all in the gulls. We'll get them picked up. We'll get it out of there. Life never goes the way you expect. We have about a quart instead of 3 quarts, and that's fine. A lot of it is in the dredges of the other stuff. It acts like a sponge. We could have certainly spent a lot more time and effort on it. Not worth it for us, so we just didn't. So yeah, we have about a quart. So what I'm going to do is I'm going to go ahead and pour this back in to the pot. And that's already a pretty nice, gorgeous, dark color, but that obviously isn't ink yet. We're going to go ahead and get the scale, tear it out again. Let's see, are we in grams? Yeah, we're in grams. So, 28 grams to an ounce. Okay, that's 32 grams. Am I going to complain about 4 grams? No. I don't know how much tannic acid we actually have in there. And oh, by the way, this is a lot less anyway, right? So it's about a third of what I needed. So 28 grams, a third of that, 10, right? Well, that means I need to have 21 when I'm done. Because, just thought of that. Because this is way too much for what we have. See what I got. 8 grams. So, oh well. But now come look at this. That's not brown black. That's black now. And it's pretty instant. So,
Yeah,
oops.
that's crazy.
Wow.
Yeah. Now that's not ink yet. It is. So what happened? Why did it turn black? So the tannic acid added oxygen to the iron, and we have, and then some electrons bounced around and did some funny things because chemistry is weird, and I can't explain the process to you as a chemist because I'm not one, but it went from being iron 2 sulfate, went 1 molecule to 1 sulfate, to now being iron 3. Is it iron 3? But anyway, and oxygenated, and so we rusted it. Okay, it's oxidized iron, but it's the stable oxidization of iron. When we think of oxidization of iron, we think of rust. We think of that red rust, right? And that's not very stable. And in fact, it grows and it kind of eats away at things. However, this is the kind of black that you get from your cast iron pot, cast iron skillet. It's a stable oxidization. And in fact, tannic acid has been used by museums to coat their iron things so that they become black and stay stable so that the red rust doesn't happen. But that's what we have, and it's in liquid form. And that's kind of a weird thought. But it's not ink yet, it's a dye. Okay? What's the difference between dye, paint, and ink? Short answer, which is never always the right answer, but it's a good answer, it gives you an idea, is that dyes fundamentally change what they come in contact with, okay? Which means it's been stained. What's the difference between a stain and a dye? Well, it's kind of like the difference between a weed and not a weed. You wanted it there, okay? That's what a dye is. You want it there, okay? Otherwise, it's a stain, right? So that's what it does, okay? Paints, they're on the surface. They get you paint on it. You come along later, you can scrape it off, and oh, look, it's still the same color it originally was. Ink is that intermediary substance where it bites in and sits on top, okay? This right now is just a dye. Okay, and it will dye things well. Could you use it to write with? Yes, because you're going to have a good flow to it. If you're an ink person and all this stuff, it's going to be hard to control. You can do it. It is possible, but why fight it if you don't have to? And that is where gum arabic comes in. Now, you'll notice I have it bagged up pretty well, but that's because this is an old bag and has holes in it. Okay? So, take that off, tear that. Come on, there we go, wake up. And we need about an ounce. Again, an ounce is 28 grams. It's on grams right now. You notice these are gum arabic crystals. You can buy these all sorts of places that do art products. These came from Kramer Pigments years and years and years ago. Because if you use it an ounce at a time and you buy a kilogram is 2.2 pounds, that's 32 plus. Yeah, that's a lot of batches of ink if you're only using an ounce at a time.
Now, would we still use an ounce since we're making less ink?
If we want a good thick one, yes.
Okay. Because this just has to do with the viscosity.
Yep.
Okay.
No.
Not viscosity, the...
Well, actually, so yes, it has to do with the viscosity. Viscosity is flow. And now things get complicated because we're talking about water dynamics or fluid dynamics. And one of the things before we get there, but I'll show you how this is. It's not just one color, is it? You have white, there's a little pieces of bark in there, amber color, dark brown color. And so there'll be some recipes that say, use good colored. What the heck was that? Let me get out the crystal. What they mean is that. Okay, now when you're going to make a black ink, who cares? Okay, but when you're making pigments, where the color needs to not change, then yeah, you want the clear, quote, white crystal stuff. This other stuff is going to change it a little bit. Is it enough? Well, it can be. So yeah, you spend your time going through it, and that's, as the saying goes, what apprentices were for. You had them go through and sort out the stuff. Because that way they learned, and they knew what to get, and they knew how to do it, and you didn't have to. Because you did it when you were an apprentice. Screw that, I'm not doing it again. Kind of a thing. Yeah, 28 ounces on the spot, on the nose. And if I dump all of that in there, we're going to have a good thick ink. But you then can, so it's going to talk about flow rate. So we're talking about viscosity, right? And the thing that most people have any idea with the deal with viscosity is like car oil. Okay? The higher the number, the more viscous it is, right? So the smaller the number, the less viscous it is. Now, you can run viscosity tests on this, and there are people that have probably. I'm not one of those, so I don't know what the viscosity on this is. But I do know that the more gum arabic I have, the more viscous the material becomes. And that changes. Viscosity is literally a measurement of flow rate. All right? And if your ink is flowing a certain way on your pen, you have to deal with that flow rate. And if your pen is like this, okay, and your paper is like this, you need a higher flow rate because it really isn't going anywhere. And as that tilts, you need that viscosity to go up. Now, 45 to 60 degrees is pretty common. 30 degrees is less common, and 75 degrees for a slope is something that we've seen, but according to the amounts of paintings that we have seen on them and ones that have remained behind, that wasn't so common. Do we really know what the census was? Who did the most where? No, we don't. We can only guess based on historical records and what's left. And the records that we have are paintings usually. So we don't know. I use one that's at 45 degrees. I found that I like 60 better, but I could afford the one that was at 45, so that's what I got. But yeah, so the more this slant goes to 0, then you want more gum arabic in it. Not that I'm going to do that. Let's see how I did. Should be about half. Oh, no. We're down 6 grams. And now we're on 19. So yeah, that's good. We're going to stop there. And then this stuff I can put back. Now what do? Okay, you have a couple of choices. First of all, we had to squeeze this out by hand, so it's cold. All right? It's cold because it would hurt otherwise. So now you can either heat this back up, and that will increase the chemical reaction, more energy, you get more reaction, and it'll melt. Or you can just leave it there for a week and then use it because it'll be dissolved in it, and then you can stir it occasionally so that new parts of it get there. And if you're really, really smart, you go ahead and you start soaking some gum arabic like 2-3 days before, and then you just pour it in. And you're like, yay, I'm done, and I didn't have to work hard at it. Which I didn't do this time because it's not as visual, and well, when you're trying to show people how things work, look, I poured water in. It's not that doesn't work. All right. So at this point, we're done to a point. You want to take it, you want to put it in a container where it can be stored. This is what I use. Weirdly, I don't know why, but most people seem to use this for like tea or lemonade. I don't know why. Probably because it works really, really well. Obviously, it's going to work well for ink. And that way, I can do that and get poured into a bottle. And I have an easier flow rate. And that's what I came up with. But whatever works for you. If you want to use a baster, like a turkey baster, let me warn you that turkey baster better work really, really well, because it's going to want to come down out the side anyway. Ask me how I know. But yeah, some version of this is what I have found to be best. The thing is, though, is that this is acidic. You can throw in things like eggshells, baking soda, anything that after it's done all its stuff, and that'll raise the pH. And as the number goes, the lower the number, the more acidic. Once it hits 7, that's neutral, and then once it goes above that, it becomes alkaline or a base. And so this, I've gotten, I've tested my inks. I've had everything from 2.2 to 5.5. 5.5, by the way, these days is roughly rainwater. And so yeah, it just depends on what you add to it. If you're afraid of the acid, then you can add a base to it. Again, eggshells, chalk, baking soda, that kind of thing. Another thing about baking soda is that if you do that, do not do it in the bottle where you have a small neck. I think we've all seen that experiment with a volcano. So did I, up close and personal. Just in case I'd forgotten. So yeah, it's we're dealing with chemistry, and some of the basic chemistry that we learned in 6th grade applies here. And definitely an acid and a base, when they come together, they make water and a gas. And the gas likes to go out wherever it can find a way. So that was fun once. So, but yeah, we put in the gum arabic. This is not hot. We are not going to. I'm not going to make the people that are here wait for this to dissolve. As you saw, this already had ink in it, so we'll be using that instead. But yeah, that's ink making. Now we just got to wait for the gum arabic to dissolve in the next day or week or whatever, and it's not going to matter because we have lots of others. All right. Thanks so much. Hope you all have a good day.